Hello everyone. So today I will be talking about electron beam welding. Okay. So actually electron beam welding and laser beam welding. So both will be studied side by side. So first I will talk about electron beam welding. Then we will talk about laser beam welding. So this is the diagram which you can see here. Actually it's electron beam welding setup. So you can understand the size of the machine tool which is used. So it's not uh, very small actually, and the cost is very high. I'll tell that why this cost is too much. So let's talk about EBW and LBW. So both type of building actually they utilize concentrated beam of energy which is precisely controlled. Okay, so generally EBW, electron beam, so obviously it is using electron beam which is accelerated and is deflected with the help of magnets to focus on job, because electron obviously it's negatively charged, so it can be deflected easily. In laser beam, we are using laser, which is known as amplified light, okay, and that is focused with the help of lens on the job. Now, the main point which you have to remember in this complete class is this point. Okay, if you forget all the points, still, if you remember this one, that is enough. That EBW, that is electron beam welding, delivers deeper penetration welds than any other process. Okay, why it happens, that we will see. That is the main advantage of electron beam welding, that we get very deep penetration, and above all what we get is, it is written 2-inch deep in a steel with a width of less than 0.2 inches. That means the heat affected zone is very small. Okay, so the chances for distortion is very less. So you can see here and also the heat which is required, actually heat which is delivered by electron beam welding is very less, and due to this the job will not be distorting because of a lot of heat present there. Okay, so that is a great advantage of electron beam welding. So that much is to be remembered in this electron beam welding. Other things are not so important as this one. That first of all, deeper penetration. Second is less distortion. Okay, so that's the point. Okay, now we will talk about in detail about electron beam welding. So electron beam welding is a fusion welding. Obviously it is a fusion welding in which coalescence, I have talked about what is coalescence. Coalescence means mixing of metals, two metals. So coalescence is produced by heating the workpiece due to impingement of concentrated electron beam of high kinetic energy of the workpiece. So what happens, that a electron beam which is accelerated at very high speed, and that is allowed to fall over the job surface. Okay, so the whole kinetic energy converted into heat energy, and in this way the point there that melts. As the electron beam impinges the workpiece, kinetic energy of the electron beams convert into thermal energy, resulting in melting and even evaporation of the work material. See, so melting and evaporation also happens. Are you getting? So the point at which the beam is falling, so their metal evaporates. Okay, and a keyhole, we have talked about the keyhole. So a keyhole is formed there. Now what are the principles? So first is point is that electron beam welding is carried out in vacuum generally. Okay, generally if you want more benefit out of this electron beam welding, then you have to carry it out in vacuum. So here what is done, there is a filament, that is tungsten filament, so that is heated up to a certain temperature. Now you can use any method of heating, but generally electricity is used to heat that filament. So when you heat the filament, then from there electrons are emitted, and that electrons is accelerated, okay, by applying high potential difference. How much potential difference? कितना? तो हम लोग जो यूज करते हैं घर पे वो कितना होता है, 220 वोल्ट या 440 वोल्ट. हियर यू सी मिनिमम 30,000 वोल्ट. सो not 220, not 440, it is 30,000 volt minimum, and it can go up to 175 kilovolt. That much voltage is applied. Now you can understand the speed of that is gained by the electron beam. So this voltage accelerates the electron beam at a very high speed, okay, and it travels from cathode to anode. So it is generated, it is starting from cathode and it is going towards anode. Okay, now what is the if you increase the potential difference, there obviously the acceleration will be higher. And how much speed it gains? 70% of up to, means you can say a speed of light 3.10 to the power 3 into 10 to the power 8 meter per second. It reaches up to 2 into 10 to the power 8 meter per second. So that much speed it gains. So that's the great thing about it. You can see here 2 into 10 to the power 8 meter per second. That much speed it gets, means 70% of, just remember this one, 70% of speed of light. That's all. So that much speed you can get it. Now electron beam is accelerated already, but now we need to focus it, okay, so that it can be focused on very small surface, not it is scattered here and there. So for that we use magnetic lenses. That means magnets, electromagnets are used, and that makes it concentrated. When this high kinetic energy electron beam strikes on the workpiece, high heat is generated on the workpiece, resulting in melting of the work material. Now molten metal fills into the gap between parts to be joined. See, so what is happening, as soon as the electron beam falls over here, then their keyhole is formed, very deep hole is formed, okay, because the metal from there is evaporated, okay, and then when it travels, then in that keyhole, okay, that deep hole, that is also traveling with the beam. So the previous hole, like the hole which is prepared earlier, so that is filled by the molten metal which is coming